Good, Dave.
Hi Marcin, how are you?
Hold on, let me get my headphones. There we go. How did it go?
Was a great visit. What I learned based on the blueberry plant, and also about the project we're doing together of the integration of a pod for hydroponics. Everything is feasible.
Okay.
We found it feasible, first of all, which was the main thing to define, and interesting to innovate in the cost perspective. So doing the biochar and the filament with HDPE or other type of plastic, that's totally feasible. He has done with different materials, and the end goal is not the material kind, it's more the water retention,
Mm-hmm.
and I would say the ability to create oxygen in the material construction. By
Aha.
this is the feasibility we were looking for on the growing media. The rest, I mean the printing of the pot with the integrated drip system, that's also feasible. It's just the design of being able to do it in a cost-effective way
Mm-hmm.
with a printer and also with the recycling of plastics
Yeah.
to make it more cost-effective. And the water recycling part, that's also feasible too. It's just understanding the chemicals components of the water in order to be able to treat it when it's recycled. So that's something simple. It's just a water analysis in order to see how to treat water. That's it. Now, my goal would be create.
You okay?
Yeah, can you hear me?
Yeah, I can hear you. Your goal is to create.
To create basically the whole concept. What I see is an integrated pod through open source ecology. So my question now is,
Mm-hmm.
where would you start? This is a material analysis and also a cost analysis thing.
Mm-hmm. Okay. Okay. So, great. Let's do it. Okay. Um,
Yes.
so, as we go forward right now, priorities. Absolute priority is what? So, what are we doing first?
Understanding the cost of materials. And for doing that is go from the four main machinery that this will take. I understand is the 3D printer, the plastic extruder, the pyrolysis machine, and I think I'm forgetting one, but I have the document here.
Shredder.
So
Shredder. Shredder,
yeah,
filament maker. Materials handling is involved too. Um,
of course. And the pelletizer, just to make it as more.
pelletizer. So you want to start burning pellets. You want mass flow, easy material handling. So you want pellets.
That's what we talked
Yeah,
last
we talked
call,
about it. Mm-hmm.
and I still have that idea.
Okay.
But still, I have to organize my mind, and your experience here would be really welcome to understand what's the first step to do.
Okay. So you can generate biochar like right now, but maybe I don't know if efficiently. If you do, if you make pellets, then you've got mass and easily flowable and handleable, storable. Like you can store it in, I don't know, I guess 55-gallon drums or something. Um, so you have feedstock that you then would pulverize to. Okay, so you need a little ball mill or rod mill, but you want to pulverize that, and then you're feeding that into the 3D printer filament maker. So you got to have a mixing, but I think that mixing, if you've got pellets of plastic or shredded plastic, and you've got the char in it, maybe you can actually, oh man, interestingly, pellet size and plastic pellet size, so wood pellet, i.e. charcoal pellet, and plastic pellets are similar in size, so if you maybe just co-extrude them together, maybe that's just enough. You don't even have to, I'm not sure if you have to shred it or not, but probably you might, I don't know that answer. We can look into it. So let's go to a dock, and so you want to start 3D printing stuff. So the pots are first, then, and biochar medium integrated pot system with recirculation. So are we forgetting about the other things at present? I mean, of course they're in the background, but netting, other stuff, harvester, is that still? That's for later or just now? Now we got to do the integrated pot system.
That's for later, correct.
Okay,
Let's
later.
break it the pod system. I would say that the bird net, I want to solve it with a bird laser.
Mm-hmm. Okay. Bird laser, cool.
And the harvester, I think that's a very big component,
Mm-hmm.
but it would be smart, in my perspective, just to get a commercial one, understand it really well how it works,
Mm-hmm.
and after find out if we can make something as good at a better cost.
Well, the answer is, of course, yes. The question is, do you want to spend the development time to do it?
Yes, but I want to also start scaling the project.
Yeah, and
And if
then.
we do the pods first, that's
Mm-hmm.
going to give us much better advantage in cost
Mm-hmm.
to make the
Mm-hmm.
project now and then still innovate later for all the other components.
Okay. So I would say let's start with a one page that says time, like critical path timeline kind of a thing. So under open source blueberries, we've got a working doc.
Could you
Let's.
could you paste it here in the chat just to be on the same doc?
Mm-hmm. So I'm going to the conceptual design doc. Same one as before. All right, so I'm gonna go up to page. So basically, starting new pages on top, so that latest stuff on top. Okay, so slide, duplicate, slide. I'm gonna start. Let's do critical path, like basics of critical path, like by year, because you're talking about how do all the other parts fit into this program so we don't lose track. Yeah.
Yes.
Okay, so we're gonna start with integrated growing pot. I like the word integrated. Mm-hmm. With water recirculation. Okay, you're in the dock.
Yeah.
I see you. So we can maybe do some. So critical path, I'm gonna go. And then let's take some notes.
Just as a comment, this integrated pot, if we see slide number 2, where it has the biggest cost of the blueberry, this is taking the concept 2, 4, even 5, because we wouldn't need run cover, 6, and 7. So we're just leaving concept 1, which is sunshade and bird net, and concept 3, which is nursery plant. This is really taking one of the biggest costs of the whole project. That's what I want to focus on.
So stock, your genetic stock.
Yes, that's what I wanna do it later.
Mm-hmm. So for now, so we're gonna say that we're gonna put that. Well, we're gonna put that in. So this is gonna be blue or green. Let's see, can we make it dark green? That we're gonna put in. And just put it in red for later. Okay. So irrigation. For irrigation, I mean we mean the. We're not including the osmosis in it, or are we? Reverse osmosis.
That's not included on the irrigation. But it's something I want to work with.
So no reverse osmosis. So we're doing the basically the drip emitters, nozzles.
Yes, it would be a drip ring.
It would be what?
A drip ring. It's
Yeah.
basically a ring that goes around the pot that is connected to the main drip line, and it has the effect of giving the whole water into the pot in a circular way. So the full ratio of the pot, it's on a level water.
Okay, irrigation ring. I'm taking notes here.
On the other work doc I pasted, I was playing with the FreeCAD,
Which
and
other
I
work
did
doc?
on the chat.
Mm-hmm.
That's I'm gonna paste it again.
Yeah.
And the plan is to integrate it on a single Word document. It's just that for the presentation with the advisor, I was working on a specific document to be able to present to him.
Mm-hmm. Yeah.
So if you click that document,
Mm-hmm.
there is explained what I mean by the pot, the top view, the cross section, the drip ring.
Is this in the open source Blueberry development template?
I haven't put it there. No.
So we're going to open source Blueberry template.
I know I gotta start using more the wiki. I haven't even put my hours, but I've been doing at least 6 hours per day working on the open source ecology.
Yeah, do it, man. Do it. Put it in there so you count. So that
Are you
is.
mute or is that me?
Say what?
Mm.
Say it again. I'm sharing my screen. So here we're still. So what I'm seeing in this pot. This is about
Probably me.
concept.
Sorry.
Okay, this is good. Wait, is that you?
The mute?
Is that FreeCAD?
Oh yeah, it's free.
Nice.
Well, nice for FreeCAD. It's very easy to use.
Oh, that's good, man. Okay, that's the rubber hits the road when you start doing a CAD. That is good. Okay, I like it.
You sent me an email to show you with some images, and that's where I started playing with the FreeCAD, and I included into this presentation. I was able to show it to the advisor, and it really helped to understand the design on different perspectives and views.
This now can be readily upgraded. Where's the link to that file?
I gotta put it on the document.
Can you put it into this 3D CAD right now?
The macros for achieving that, I will put it there.
You did it through a macro?
Well, no, not me. I went to the chat Claude. I'm using that. I find it very straight to the point, and it delivered a full Python code, which I pasted on the macros, and then that appeared.
No way. You did
Yes.
you did chat and chat generated what I'm seeing on page 5.
Yeah, I just explained what I wanted to achieve.
Holy cow. That's amazing. That's
Yeah, it wasn't the
man.
GPT. I went into Anthropic Claude, and that's what I got.
Huh. No, I mean, this is such a game changer. I mean, this, compared to a few years ago, I mean, when you can actually talk to chat and you can generate graphics like that, I mean, we're like in a different world right now. That's really good.
Yes.
And just like during the workshop, somebody generated there's a thing called anti-gravity. You can see that on a wiki, but it allows you to do text to generate code that works with FreeCAD. So this one dude, Jackson, he generated basically modules with all the annotated dimensions and a little program that you could view all the modules online in a web browser. So for FreeCAD, during the workshop, we used it. Like I used it, I looked at it to get dimensions of modules and things like that. So this is just amazing, and it's really good promise for, I mean, getting to the zero marginal cost society, because now you can just say, you can now tell chat what you want. We're collaborating with AI to do what we want, and then you can throw that into digital fabrication means, including 3D printers and CNC torch tables, and you've got physical reality at zero
Yeah,
marginal cost. It's beautiful.
that's a goal.
Mm-hmm.
It is.
Yep. Um, can you dig that up and throw that in there so we have one so you can put it. Let's see, am I sharing the screen? Yeah, I'm still saying. Can you throw it into line item 5?
Yes. I'm
I
just
mean,
gonna need. I'm gonna need 2 minutes because it's on the chat's memory, so I gotta look for
okay.
it.
Yeah, learn the habit of documenting real time, because I'm telling you, if you're not gonna do it, you're gonna get a backlog, and this will never happen. This will never get documented. So you got to do it in real time all the time. That's the discipline you need to develop,
Agree.
and that's under the principles of time binding and economic time binding. I'm gonna look at your doc in the meantime. On slide 3, did you generate these diagrams, or you picked it off from somewhere else?
One moment. Slide 3.
Yeah. Is that actually your content, or you just copied and pasted from somewhere else?
Which presentation are you?
In the integrated biochar blueberry pot.
That was made on the chat.
Oh, you generated that through chat?
Correct.
Oh, wow.
Yes.
Yeah, that's good. That's good. Okay, drip ring. Uh-huh. Is page 4 macro, or that's just concept drawing from chat? Is that FreeCAD or chat?
No, that was a drawing from chat.
Okay. So I'm surprised it actually does this well for drawings. Yeah, it's learning fast. Bioplast.
So I found the code. I'm here in the open source ecology wiki, open source Blueberry production.
Uh-huh.
Then I go into 3D CAD.
Yeah, yeah, do that there. Though now that you're doing it that way, it also belongs at 9, but just go to 3D CAD since that's CAD generation. So
3D
click
CAD design.
go into so link to work product. Here you see my screen? Right there where my hand is.
One moment. I cannot see your screen yet.
You cannot see my screen?
I have a few windows open, so okay, I can see it now.
Yeah. So that's 3D CAD.
Yeah.
I want to see that turn blue.
I'm on 3D CAD. I click there just to upload. I do edit.
Yeah, yeah. Edit. So you gotta be logged into the wiki. Edit.
Yes. And I see an edit window there, but there's some text which says process overview. Do I just erase that?
Um, let's see. Open source blueberry production. Let me see what I get there. It should be. You see my screen? That's what you should be seeing.
I see it. It's just I see editing 3D CAD design, not what I'm looking at your screen.
Yeah, you got. I'm not. So you see my screen? It's a blank page, and you go to the bottom, and it says save page.
Got it. Did you got it now? On the wiki?
Let me see. Yeah. Okay. Did it.
So that's what I should be doing. Okay, first time.
That's it. Okay. So FreeCAD Python script. Um. Okay. Then. Okay. So you basically followed the instructions that chat gave you, and you just did that. You ran it, and that's it. Yeah.
Yes.
Okay. I'm gonna. Let me see. Can I just do that myself? So, if is this how long did it take you to run the script?
On FreeCAD?
Yeah. It's like a minute or two.
No, 30 seconds.
Okay, so I'm copying and I want to replicate what you just did. So I'm gonna copy and paste.
Yes, I went to FreeCAD. I opened macros.
Yep.
Then I did create. I pasted exactly this text. Then I click run macros. And then it gave me the opportunity to see the concept.
Okay. Now, was that FreeCAD 1 or old FreeCAD?
I'm not really sure. I did it on my Mac computer, so I went into freecad.com. I downloaded for Mac, and I just followed these steps.
Yeah, it's 1. So I'm gonna cancel. So I'm gonna go. I'm just gonna go to Sketcher Workbench. I'm gonna go macro, macros, macro name. So I'm gonna go create. I'm gonna say
Yes.
pot, integrated pot, integ pot.
I call it OC pot, open source ecology pot.
Okay, so it does that. I'm gonna just paste it. No, I gotta copy. Gotta copy your content again. Sorry, this. Let me just fix my screen here. It's messing up. 3.
You have three screens in front of you.
Yeah, I do.
That's nice.
Yeah, it's useful, quite useful. Um,
Yes.
yeah, it's nice. Um, let's go back. Try go back to the other. Um, okay, so I'm gonna go. So I'm gonna go Control A on this. Control C. I'm gonna go back to FreeCAD, and I don't know. I had this other paste thing in there, so I'm gonna Control V. Okay, great. Where do I hit save? Where's my save? Save button.
I just went into macros menu and I did execute macros.
Okay, so OSC pod FC macro, it created it. It didn't. There wasn't like no save button. After I pasted it, it just understood it and saved it itself. So I'm gonna do
If you
that. I'm gonna execute. Let's see what happens. Well, I probably have to have a new file open. So I've got this file open, macros, that, execute. Nothing happened.
if you do it again, but through the menu, you go macros,
Okay, so I'm gonna go macros.
then yes,
I'm
then
gonna
create.
double click on. I double clicked on it, so it should have. Nope. Let's try it again. Macros. OSC pot macro. So it's either execute, close, download.
What I did is just I did it with the menu, the macros menu. So when I pasted the code,
Oh, there's nothing there. So it did. Okay, it didn't save it properly. So I'm doing it again, and then
going to macros, if you open that menu, you're gonna see execute macro, and I click there, and then it starts doing the work.
let's see. It's giving me the spinning wheel. Is that what it did for you? Oh.
Yes,
Oh.
probably, and that's how I got the pot.
Oh, nice.
Then I started
Nice.
playing with the different components in order to be able to take the right photograph and be able to explain the advisor what I was trying to do. So just talking with the chat, I was able to explain what I was trying to do. I showed in the Word document what we draw together on the Word document, and then the chat was able to understand where I was going to.
Uh-huh. That's
So as
amazing.
you, yeah, you can see the drip ring, you can see the recovery water base, you
Mm-hmm.
can see the body pot. So yeah, it's very amazing.
Look at that. So you
And
got the water area below. What's the hole?
this hole is for the water to go into a drip line where it goes into the recovery reservoir.
Recovery, yeah. Okay.
So there's the false bottom that you're seeing there.
Yeah.
So for the growing media to be separate to the recovery area. And hole you mentioned just below is just for the final water to be able to be recycled into the reservoir.
What are the slots? Is that aeration?
The growing media is not included into that pot.
I'm asking about these slots.
But by slots, I'm not sure about the concept.
It's, you didn't put it in there for aeration, so that's, what is that? Is that an unknown artifact?
That's the false base. And what I mean by, by this is the separation of the growing media and the recycling part of water.
No, but so that's the false bottom. But what about these things?
Oh, got it. And no idea.
It's a it's just an artifact that we don't know about.
Correct.
Okay, so that like a little BS from chat.
For sure, yes.
BS injection. Well, is that called that's called hallucination, or what's the technical term for when AI gives you funny business?
Yes, hallucination.
Yeah, so it's
That's
a
what.
hallucination. Yeah. those those things there, that's a hallucination.
Yes, or something not asked for.
Mm-hmm. Yeah. Okay. So yeah. In terms of fabrication, we then have to consider manufacturability and printability of a ring like that. Is, you see that ring, it hangs in midair, so you can't print it. So we have to modify this to do something a little different, and that's doable. That's why you've got those. Do you understand the teardrop shapes in RepRap?
No.
So um, yeah. Okay, we're gonna quit out of here. Or let's see, view perspective. I'm gonna copy this because I'm proud of having replicated that. So this is replicable. People can take this and run the macro.
Yes.
I'm gonna copy that. Okay. Um, so we've got this. So when we go back to 3D CAD under open source blueberries, we got this. Great. So we might want to make a note here. This is a. I'm gonna put a little hint here. This is a FreeCAD macro for generating a pot. V0.1 of pot with yeah. So I'm just putting this little thing. Mm-hmm.
Yes.
Okay. Back to this. So in this, let's see, can I edit this? Is this editable, or are you making it?
Yeah, I shared that presentation with you and Elisa, so you should be able to edit by yourself.
I'm not able to edit right now. Let's see. You've
Okay.
got general access, anyone with a link, viewer. So I'm logged in as me, but I don't see the edit. Like I can't
One
edit
moment.
it. But I wanted to start
Oh, right.
commenting on it.
Yeah. One moment. Can you do it now?
Yeah, I can do it. So in 3D printing, what happens is you can print something of this shape, like You know, the teardrop from RepRap. This is where it comes from. The RepRap logo has this teardrop. And what that refers to is that something that's actually printable in the sense that you can keep printing this. And here the overhang is so, like, because you have overhang, you can't print in air. But if you do 3D print a teardrop, you can actually print it. So you cannot print a circle well. So a circle will collapse at the top because there's overhang and you can't print, like, you know, you understand that? You can't print something that overhangs with infinite overhang, like.
You need the base. That's
Say you're printing an object, you can print vertically, but once you start going out to the outside of the object, like say you try to print this on a print bed, a pin like this. This on the bottom of a print bed. Here you're gonna start dropping. The plastic has got nothing to hang on to, so it'll fall, and you'll start getting spaghetti. Like here at this point. Actually, our printer is pretty good on this. Like we can do overhangs like this. The OSC 3D printer. There's techniques where you can do very steep angles like that, but you can't really go horizontal. Like you can't print in midair because you have nothing to gravity. There's a thing called gravity that it pulls the print down and you fail. So that applies to your ring. You can't print it in midair. So what you'd have to do is I'm going to draw the side of the pot. So this is the side of the pot. And I'm going to draw how you could print the irrigation ring. So you can go like this. You can print this. And therefore you'd have to, so that's the one side of the pot. The other side of the pot would look like this. So that's your other side of the pot. And you have the base. I'm not doing the detail too much, but just for the printing the ring, you have to go something like, put a hole, like your irrigation hole somewhere like there, because no, I'm looking for a hole, just a circle. So you can put your drip emitter here if you 3D print it. So the detail would be, how do you print that little nozzle there? But you can do a hole like that. Your ring, because it's suspended in midair, that's not printable. But if you print some kind of a nozzle in there, you know, this is your nozzle in there, in your wall of the pot. So you can do this. I would comment.
Just as a note,
Yep.
I know the drawing seems in the air, but in real life, that's going to be connected into a drip line, and it's going to go from the drip line into a small tube that is going to connect into the ring to be able to deliver water from the drip line, tube, and ring.
Yep, exactly. So how about we design integrated drip lines too? What if we designed it? How about we do this here? What if we do the drip line? Let's see, what's the most convenient place for the drip line? Let's, instead of using a separate drip line, what if we were to do, say, a nozzle, your integrated drip line is here, and there's a channel that goes up the side. So you've got a connection to the next pot, you got a channel that goes up into that ring, and you just got rid of the drip tubing. That'll save you a lot of labor. See what I'm saying?
Yes.
And then you've got, so maybe you can comment on that. So here you've got the false bottom and a reservoir. You got your reservoir. But I would suggest something like that as a first hit, because then what you can do is now you just need to connect these little pieces of tube between pots, and maybe that's So let's do a curve here. So no, not a curve. Do a curve like that. So now you've got one pot connected to the next pot just through a tube like that. I don't know, maybe that works. But I'm looking for ways to like put everything into the pot so that you don't have like a whole tubing system. You just got interconnects between pots. So I'm drawing over your picture, but let's put this onto the next page. Can I create a new page here?
Yes.
So I'm gonna go. Okay, so actually I got this here. So irrigation ring. So here's your pot with a tube connecting one pot to the next. Would that be cool, or I don't know? Could be. So you got your irrigation ring. Let me see. So let's start labeling this. So irrigation ring. And now you can definitely ask Chat to now make that 3D printable. It might understand it. I don't know. Because you can teach it to say, well, you can't have overhangs that it will understand overhangs. So you can teach it, nah, you can't print that. You got to print something like this. So this is your 3D printed irrigation ring, 3D printable irrigation ring. And there you go. So, but we got distracted into like what I wanted to do first is maybe start with this critical path idea. So let's talk about how the big picture things fit into this. So you got the integrated pot with water recirculation, and we already started. You already got some CAD on it, and you're moving forward. We just need some machines to print it and build it. So there's the pot, the whole let's just start mapping out this whole ecosystem. So you got shredder. So you're gonna start with garbage bales. How about we start with garbage bales? They're near free, $50 a ton, or $100 a ton. Do you like that?
Garbage pail. So
Do you want to do that, or do we want to source regrind? So you can do garbage bales. You can do regrind.
I'm open to any alternative.
Yeah, let's examine plastic garbage bales and regrind. The regrind is going to be more expensive probably, but not necessarily, because what did I say? Was it 14 cents a pound for the thermoplastic urethane? Do you remember? I forget
No.
what we said, but it was pretty low. I'm gonna go to. I like the icons. Let's see. GCS icons on the wiki. Let's pick out the shredder. Okay, the images are right here. So let's take. Okay, we're gonna need this. We're gonna need an extruder. We're gonna need this is a hammer mill kind of shredder thing. Let's use that for now. So that could be our shredder. Wait, I don't know if we're gonna I don't know if we're gonna get into actually making any of these machines with a CNC torch table, but we can examine that for cost reduction. Let me go to the smaller icons. These are too big. So I'm gonna go to what else we got here. We got, oh, that's the pelletizer right there.
Yeah, on slide number 31, I did some hyperlinks for the 3D printer, plastic extruder, pelletizer, and pyrolysis machine. All of those on open source wiki.
Where? Here?
Slide 31.
Okay. Printer, definitely, yeah. Extruder, I think we got. Yep. Pelletizer, we got. Pyrolysis. Well, we can do the gasifier. For that, we actually have a gasifier in the system, and that's the gasifier. But a gasifier is also a pyrolysis device as well, so we can kind of use that.
Yeah, if we talk about cost, and yes, I'm obsessed in cost because that's feasibility first step to make this on scale. Which tool should we use?
Off the shelf versus DIY versus open source.
No, I meant exactly what you're doing. Are all those the tools we need?
Yeah. Well, I mean, we're going to decide that. We're going to talk about. So if you do a shredder, this is if you take plastic bales, you're going to take the shred them. So let's go through the ecosystem of tools and machines required, and we can also put a timeline to it. So bales, you need a shredder, then you're going to go to an extruder, and you got your 3D printing filament. So after that, you got 3D printer. And after that, you're feeding. So you also got pelletizer. So this can represent the pelletizer plus gasifier could represent your biochar production system. You can also look at buying biochar. I mean, we can look at that too. But so probably the assignment would be, let's get a cost analysis for if you buy this off the shelf versus make your own tools to do so. Okay, so this product of this biochar production system would feed into your extruder. There's right into that hopper. And then you have 3D printing filament, and then you get your pot. Let me see, do I still have that FreeCAD open? Yeah, I'm gonna copy that. So you got copy, and then you got your pot here. So that would be kind of the workflow. So you could do either the garbage bales. If you go regrind, then you go straight from regrind to here. You don't need to shred it. Does that make sense?
Yes, doing the least possible to get the best possible.
Yeah, the torch table lies on the side. It's a spectator because you can make some of these machines. So that's that. That's the pot. But let's talk about the other product ecologies here. So, integrated growing pot, is that 4 years or 1 year? Like
No, 1 year at max.
1 year max. Okay, good.
Faster would be better.
1 year max. We got 1 year to do this. All right.
2006 pot. It's gonna be.
Say it again.
It's gonna be in 2026 pot.
2026.
Yeah.
Okay. Now, so 3D printer. Yeah. So what's in 2027?
Structures.
Structures?
Yeah, sunshade, bird net. I would say heat management and bird management. And also on the structure part, the cooling system,
Cooling for forcing
heat management
for what?
for heat management during certain months. I want to be able to analyze. Well, we already analyzed the costs per kilowatt on solar panels. So I want to be make a solution to use that cost of kilowatt and put it on a structure for certain months of the year
Hmm.
to be able to cool what's inside.
Okay. Let's go back. Yep. So cooling for heat management. So do some. So let's talk about agrivoltaics for
Yeah.
now. Let's see. Cooling for heat management. Are you looking more at agrivoltaics for that, or structures, or other structures? I mean, we'll have to determine that, right? Um,
Everything be defined by cost in my perspective and I call of course effectiveness. But at one point
yeah.
you talk about the bricks that you can make with soil
Yeah.
that would really make an effect of cooling. So it doesn't need to be agrivoltaics. It could be also constructing with bricks that are made of soil that could make that direct effect of reducing the heat inside the
Yeah.
structure.
If we talk about, like, one thing that comes immediately for dirt cheap is bricks, and you span that with your sunshade. Yeah, I mean, so it's really, there's a lot of links there. I'm definitely seeing something like, so structures. Well, this is like cooling for heat management is CBR. I mean, the sunshade connects to cooling, so you want to integrate sunshade with cooling, but you also, I mean, that's also integrated with. I'm drawing this in a line, but I think, let's see, let's go to. No, I'm gonna keep it linear here because. Okay, so agrivoltaics are related here. Um, Agrivoltaics are related to structures. Bird management. Let's see. I mean, if you've got bird management as a requirement, I mean, it's possible that the shading can. Wait. Let's run through that logic again. Would shading be a feasible way to do bird management too? Yes, if you could remove it, right?
By removing, you mean the sides or the ceiling?
Ceiling.
And the sides would be fixed, correct? Oh, yeah, that's feasible.
Mm-hmm. Yeah. Okay. Sunshade. I mean, these are all related. structures for bird management. So it could be a combo. In a product ecology, there's going to be a lot of complex relationships. Cooling for heat management could be related to the bird management if the sunshade is bird shade. I mean, yeah, they're all. So if you drew them in a circle, there would be an arrow between each and every one, you know?
Yes.
So it's a circle with where every item is connected to another. So you got this. Yeah, I mean basically everything is connected to. So because you can multitask with these things. Okay, so that's 2027. What do we got for 2028?
The freeze-dried near marginal cost and the reverse osmosis at near zero marginal cost.
Oh.
But I'm really hoping to be able to make all this in 2026.
All these three things?
I say I'm hoping, yes.
What resources do you have to accomplish that? How much resource are you willing to put into that? Financial and other?
I don't have an exact number now, but I have a business model with the blueberries and also with the freeze-dried ingredients.
Okay, business model. Would that business model rely on capital that you have, or would this be loaned or stuff like that? Existing capital
Both.
or loans?
Both.
Both. Mm-hmm.
I mean, if we get there at really attractive cost, I will be willing to put my money because I know how fast would I recover this. The reason I take loans on businesses is because it takes a lot of time to get my money back. But if I see the return of investment and also the margins going extremely fast because of the effectiveness of doing open source, that takes another approach. That I could really put some money, some savings I have, and make it really fast. If that's the concern that would stop this.
That's a good way to think. No, you're thinking in the right way in terms of scalability. Development time is an issue. It's a question of integrating this know-how. Now you can go between open source and commercially viable, just commercial machines. Now, the complexity is gonna get you, all the operating costs and things are gonna get you using commercial machines due to the higher cost of maintenance and service and all that. So I can't tell right now how it would look for the feasibility of open source techniques to do it. I mean, my immediate statement is go. I think the thought where you say, okay, here's the return on investment. If you could get that funded, then put in large amounts of resource into the development when you know that you can do it because you're enlightened and you see the open source economics. That is possible. That with that kind of logic, what you're saying is crazy. Your crazy exponential growth can happen in 2026. In terms of your own time, do you have distractions on your plate? Hold on, for 2028. We said freeze-dried fruit powders, harvester, and what else?
I said freeze-dried powders. Well, freeze-dried process more than powders, and that would include the the near zero marginal cost of kilowatts, and the building of the machinery. That's it. Shouldn't be more complicated. The machinery already exists. It would be just the development of it in-house and the integration of the PV panels to create at least 8 hours of process at near zero marginal cost,
Yep.
or as we saw at zero point zero 0.01 USD cents per kilowatt.
Oh man. And then you can put in all those those profits to open source the machine.
Yeah, and on that same concept will be the reverse osmosis, creating the components, which are basically filters, some steel, structure steel that could be created with CNC, some sensors,
Mm-hmm.
and also the same kilowatt cost structure.
What percentage? So for freeze-dried fruit powders, we said, remind me the cost structure. You said that, what was it? 80% is energy cost, or no? Remind me.
60% is energy cost.
60% is energy cost. So immediately, pretty much, you're gonna gain an advantage of 60% better performance, right? Because we're gonna get that down to very low cost.
Yes, and 30% is the cost of fresh food, like fruits, on this concept, and that I have it solved because I have fruit farms and I have waste. So the reality, if we are able to achieve it through the energy cost, I think there's a lot of food that is going to waste, and it shouldn't be as expensive as we see it on the different profit and loss statements of this kind of business.
Did you say that you have the fruit cost is addressed because you've got waste?
Correct.
Okay.
And not just every single farmer.
So you're saying that right now you can you can reduce the cost, assuming low energy cost, pretty much 90%.
Correct.
If you do that, that's explosion, right?
Very
For your
much.
economic potential, yes. Is the
Economic.
10% machines that
No,
actually?
labor, certifications, logistics to put it on the point where it's going to be purchased. It's more of operational expenditure and also humans that collaborate.
Where's the where's the machine costs in that? It's in the 10%. The actual
Not with,
drying machine.
well, if you put it on an amount of years and you put a certain cost per kilogram, yeah, you can call it on that 10%.
But it's a small
When,
fraction.
yeah, it depends on the volume that you can process on the same machine and your business model of how many kilograms are you going to do. So that's very variable.
But the big ticket items are 30% fruit and 60% energy, and then a 10% for everything else.
On each kilogram produced, yes. But of course, if you want to start a business and you're going to buy a big machinery, then you got to go to the bank or your savings and put a few $1,000. Not a few. Some depends on the scale that you want to do.
Sorry, repeat that. You're saying if you, so these are per kilogram. Upon
Yes,
startup, you've got the cold start and capitalization problem, right?
correct, because of the cost of the machinery.
Yeah, right. And infrastructures and all of that. Um,
But yeah,
if we can get
if you,
low cost infrastructure, that yeah, that helps all of that. Um,
I mean, you can rent a room. I mean, a building that has already certain structure and just adapt certain parts of it to be able to do this process.
so could this be a part of getting the apprenticeship funded in Mexico and exploding in Mexico before before America? No, we got to do the. Okay, so there's the real opportunity within our work on housing. I see this, if you've got a working farm with excess fruit, and we have to address energy. Um, let's look at this energy costing. Let's just real quick, because what if we get, the way I'm looking at it is those PVs, if we do it zero marginal cost style, I think the payback is about a year.
Probably. And you mentioned Mexico or US. What I'm focusing on is on the desert. So could be Sonora. We have a lot of sun hours. Could be Arizona. They have a lot of sun hours.
Yeah. Um, just thinking through this. You have the market. Do you have the market?
Yes. Clients. What I don't have is the machinery and the system to do it yet. I could go on the commercial way. I could get a loan, buy it, start processing, wait for 10 years to be able to pay the bank,
Hmm.
but I don't want to do that. I discover open source. I want to do it open source, be successful myself, and be able to share my success, not my economical success directly, but the structure on how anyone can do it in
Yeah,
other
your
parts of.
business open business model,
Yes,
including open hardware to sustain it,
yes, and knowledge too, if it's
and
needed.
know-how. Yeah, which is the way to go. This is the future. Anyone watching this video will see the history unfolding. It's
Would be
true.
nice. Will be nice.
Um,
Yes.
so let's see. Let me think about that for a second. Um, Man, that really calls for an accelerated development program on that. If there's ready, if it's the machines and you have the economics and fruit, um, let's think about the energy for a second. So if you're gonna invest in low cost PV and a system to do it, um, can you actually get production contracts already to fund it, or no, or that's
Yes, that's for sure a possibility. As of now, in that particular freeze drive, with the interested clients that I have talked about, and also some agriculture funds that I've been talking that they could be investors. They're just waiting for me to develop the concept of cheap energy so that they could really analyze the opportunity. And if they don't go in, I could do it with my funds or other people funds. Right now, what I'm really stuck is going from theory. I see the opportunity,
yeah.
the documents, the machinery, but I'm not able to explain exactly which steps I will take with which hardware and how much that's going to cost and how we're going to achieve it. That's why I'm so obsessed on doing it as fast as possible because the market on each concept we have talked about is already there. The
Huh.
investors are already there, but I'm just stuck on the middle, seeing the future, but not being able to put it on US dollars, time, and specific components to use.
Mm-hmm. Okay. Let's review for a second. So on slide 2, we have a POTS integrated pot for 2026. Structures, sunshade, bird management, cooling and heat management, agrivoltaics, potentially, but basically addressing birds, shade, and temperature. In 2027 and 2028, we mentioned briefly freeze-dried process, harvester, and reverse osmosis. Did we miss anything?
No, but just being more conscious about what really matters the most and what could be make the biggest impact. What we're putting on 2028, which is the freeze dry process, the cost effective freeze dry process, and the reverse osmosis. Those are much more needed and could be scaled much more than doing the pot, than doing the structures for hydroponics.
So why aren't they in 2026?
because I'm obsessed with my blueberries and I want to make this happen. But I just wanted to make that note that if we're talking about humanity problems and current problems of not wasting food and being able to farm with good water, not salted water, reverse osmosis and freeze-dried process are top priorities. And if we're talking about where would we get the money faster, it would be with the freeze-dried process and after the reverse osmosis. Because as of now, we're not still on a big drought. We don't have much water, and the water we get is not that good quality. It has got more heavy, more contaminated. So if we talk about the main structures that are going to change most of the business models, I believe it's the water treatment or reverse osmosis. Just as a note, I want to make my blueberries because I've been trialing different genetics and putting my money into this for 3 years. And I'm putting my work in at least 6 hours per day. But I wanted to make this note because I see on a bigger scale the impact and what's going to really end with food waste and what's going to end with bad production of food, at least in agriculture, is going to be quality water and also have an output for the food that doesn't go to market. And freeze dried could be an excellent alternative than throwing the food away.
And you said you already have ample citrus that can be used for that.
Very much, and not just me.
What's the waste volume out of the 3 million kilograms?
At least 30%.
30%?
At least.
Is that
So
because
with
there's why? Is it because the market labor?
Well, you can say market, but honestly, yes, it's market, but it's the size, it's how the fruit looks. So the marketer doesn't accept certain qualities of fruit, even if it's full of nutrients.
Ah,
It's beauty.
oh wow.
Well, it's a beauty.
Yeah, no, I get that. We got some ugly apples here. No, I get that. Um,
Yeah,
okay, so you got that ready, and oh man, we I think you got to put the freeze drying up in queue. If so, how would it look for you to do the freeze drying and the blueberry pots all at the same time? Let's look at the economics a little more closely. So, um, your choice would depend on feasibility and speed with which this can be deployed.
yes. In reality, I think that's the main concern. How can I make this a reality?
Reality,
Because that,
okay.
that this is feasible for sure. It's already being done.
What about your emotional attachment to the blueberries? Is that the block, or is it like, what if you said, I mean, you've done it for some time. You said 3 years of investing into its development. Can you walk away, or is that psychologically bad, or is it more practical bad?
I would say practical bet because I already made commitments with certain people who invested in me
Yeah,
regarding delivering their genetics, their
yeah.
commercial ways of doing it. But honestly, Blueberry doesn't take that much time anymore. I'm
Mm-hmm.
automating most of it. It's just when we talk about, as an example, pots, that would really lower the investment I would need to do and help me scale
Yeah, that can.
faster and less risk.
Yeah.
But I can focus my energy on the freeze dry for sure, because that's going to give me, being honest, an economic opportunity faster than waiting for the blueberries to be ready to scale.
Mm-hmm. How many months? When is the relevant month for actually collecting the fruit waste from citrus? So grapefruit.
um, from November to March.
November to March.
But it doesn't have to be my fruit. there hasn't to be any specific months. As an example, November to March, you can see fruit from, let's say, from the north of Mexico. Then you have March to June, you go more to the center or south of Mexico. So food waste is everywhere. I don't see that as
The
some.
waste. What's your cost of acquisition for the waste? I mean, like dirt cheap? Like, how cheap?
If
Because you
I
said 30% is the cost of the fruit. Are you still saying it will be 30%?
no, no, not on that projection. So if I'm doing this research and I see a profit and loss statement of a certain freeze-dried company, they're gonna say that they're paying the fruit as if they go to Whole Foods, as an example, or Sprouts or whatever, Walmart. But if we go into a farmer's house or price, it's a different price. And if we go into the food waste price, it's basically, I would say, zero, because still we gotta get the fruit and move it into the packing house. But I would say it's at max 10%.
Mm-hmm. Yeah, we got to do it. Um,
Yes.
okay. So, so in a critical path, we're gonna have to go back and throw that. I mean, freeze dry process. I mean, it looks like. I mean, we're throwing that
20,
into 2026.
yes. The harvester, honestly, I don't even want to do it. I mean, the supplier I see from Serbia, I think he has this really solved, and it fits the economics of the blueberry business. As an example, if I go hand labor, that costs around $1 per kilo here in Mexico, of
Yeah.
course. If I go with this machinery, it costs about zero point zero 0.05 cents per kilo. So even if
Oh.
that machinery costs about 100,000 USD, one, the cost versus labor, yeah, that's very nice. But the ability to be able to use a machinery and do it now instead of finding people and analyzing which people is going to work, that takes the business in the whole other perspective. I don't see it as something I need to do. If I'm able to fix the pot, which the pot is not just the cost of it, it's being able to recover the water, because one of the main concerns is that we don't have water anymore, or at least not as before.
Did you say 5 cents per kilogram for harvester?
Yeah, Max.
Okay, so that's lower priority. Yeah. Now that's included. That's like lifetime cost, or
Yeah,
because breakage still that good.
still
Yeah.
not good.
Holy cow, that's pretty impressive. Let's see. What's I just want to compare that real quick. What is cost per bushel in combine harvester for corn? I just want to compare that real quick. Okay, so it's like, say, $50 an acre. How many acres? How many bushels per
I can tell you in
corn?
kilograms and on hectares, but here in Sonora, a good harvest would be 15,000 kilos per hectare.
Well, the answer here is 25 cents a bushel, but that's many kilograms. Um,
Here, as the big companies such as John Deere, they rent their their structure, their machinery, and they charge per hectare at max 4,000 pesos, which that would be $200 US. So if you take the 15 tons, which is 15,000 kilograms,
Mm-hmm.
and divide that by 4,000 pesos. Oh, sorry, the other way. 4,000 pesos divided by 15,000 kilos. That would be 0.26 pesos per kilogram. $0.01 USD per kilogram.
0.1 cent.
0.01. Okay, well, let's do 0.1 just for the reference.
0.01
0.01, yeah.
cent per kilogram.
That's on the harvest part. And on the blueberry, I mentioned 5 cents per kilogram. Of course, the value of the crop is very different, but you wanted to know the reference.
Yeah. I'm getting, like my search said, 25 cents per bushel. And how many bushels?
Kilos per bushel?
Yeah.
I don't know. Jet.
Like about 20. So I'm getting like a cent per kilogram.
Mm-hmm.
You're getting 1/100th of a cent per kilogram.
Yeah, I mentioned Mexico prices of outsourcing the harvest. And of course, it depends on your productivity per hectare. That really makes the fixed cost of per kilogram.
Okay, give me your cost again. I want to verify your 0.01 cent per kilogram. You said how much does it cost? You said 2,000 pesos? 4,000?
Around 4,000 pesos. And I divided that by 20 as the reference. $1 are 20 pesos. So I said 200.
$200.
And then a good hectare, a good productivity would be 15,000 kilos divided by 200. Well, 200 divided by 1,500 kilos. It's the 0.01 per kilogram on USD.
Yeah. Let me see. 200. Divided by 15,000. 0.01.
That's Mexico, and that's outsourcing to John Deere as an example here in my city, Obregón. That's with good productivity. There are some people that have done, as an example, 6,000 per hectare. So it depends a lot.
Per hectare. Yeah, I could verify I'll verify the numbers another time, but I'm getting 100 times more expensive in the U.S. Wait, let's validate it because that's a curious number. So I'm just saying the average corn yield is say like 175 to 188. So say near 200 bushels per acre, and it costs say $50 per acre. So 50 divided by $50 or 5,000 cents divided by 200 bushels is about 25 cents per bushel, which is a bushel is about 25 kilograms, so a cent per kilogram. Are we for real that the U.S. harvest cost is 100 times more expensive than Mexico? Is that why the U.S. buys all the food from Mexico?
But in specific on corn,
Yeah,
US corn is much cheaper. And in Mexico, the processors of tortillas, as an example, they prefer to buy it from the US because it's cheaper. And it's not cheaper by production, it's cheaper by subsidies.
Okay, because the harvest cost, I just said harvest cost is 1 cent per kilogram, whereas you're telling me that harvest cost is 100th of a cent per kilogram.
On high productivity land, yes,
And
but
bad
that's
productivity is half of that, or
half of it, yes.
yeah, but it's still 50 time difference.
Yes, still you have better support from the government for farmers, and at the end price, US corn is much cheaper than Mexican corn.
Yeah, yeah,
That's a systemic thing, not a productivity thing.
yeah. Okay, interesting. Um, okay, so but you're saying 5 cents per kilogram on the blueberries, which is a much higher value crop. So
Yes.
that's significant, but the per kilogram cost based on a kilogram, that's negligible in terms of harvesting. Wow. Okay. So harvester not so important. Reverse osmosis important. How important is reverse osmosis versus recirculation? Because recirculation saves you how much? How much do we say? Is it
30% of the water
30%?
every day.
But generating that water, do you have what's the limit to the generation of water? Is it the supply of wells or the desalination cost? Do you have? Can you dig more wells, or is all the water disappearing? Is there ample brackish water?
Yes and no. What I mean by this, of course, I could go to the sea and access the water and make my own water for the farms if I have a extremely good desalination plant that has near zero marginal cost. Right now, what I mean by no is that the water in Mexico it's 100% controlled by the government and the water districts on each city. So if I am a farmer and I want to do an acre hectare of blueberries in this case, I will have certain amount of water that they're going to deliver to me each cycle. I need to get a permit, and that permit has certain limits of water. What I'm trying to do with the recirculation is with the amount of water I get per year, being able to do more with that same water because I'm not throwing it away each irrigation cycle. I'm reusing it,
More, but only 30% more.
which is a lot. Maybe they give me certain volume, but because I recycled that 30% with that same amount that I could do, as an example, 1 hectare, I'm going to be able to do 4.5 hectares because that 30% is going to be reused on that same hectare. And the other volume, I could use it to other hectares, which are going to be recycling. So with the total volume I'll get through a year and a permit, I'm able to do more plants and more economy.
Yeah. Did you say that you do have access to the ocean? Is that a possibility?
Yeah, there's access to the ocean. I don't know about the permits yet to get the water, but access, yes, it's about 20 minutes from my home.
You want to run some pipe to your home?
No, not really, not yet.
Um, you haven't considered it because of what? Because of
Car-
infrastructure. So there's one is pipes, two is desalination. Is the desalination of seawater prohibitive compared to brackish?
Not really sure about it, but all that has stopped these innovations is the cost of it.
So you haven't considered for what reason? Because of the expense of getting pipes to your place.
Yes, and also the cost of it. Yeah, the pipe is one thing, but also getting the quality of water needed to certain crops. How much reverse osmosis would I need to do, and what will be the cost of this?
Mm-hmm. And give me just remind me of the generic numbers here. We're talking about how many liters per plant per day?
4 liters per plant per day,
4 liters per plant per day.
5,000 plants per hectare. So that's 20,000 liters. And if we go into recovery, that's 6,000 liters that I can use back.
Yeah. Let's just put these numbers down on the reverse osmosis. So, um, 20,000 liters per hectare per day.
Yes.
Mm-hmm. Can you show me a map of? Can you share your screen and show me a map on how close you are to the sea?
Yes. I'm trying to share, but I'm on Firefox now and it like blocks everything.
Blocks everything. Um, Tell me the
Also,
location again so I can Google it, map it here. What do I search for again?
you can look for this town called Tobarito. I'm gonna write it there. Or
Mm-hmm.
let me just paste the Google Map.
Yeah, paste paste the link.
Google Earth is it's
Yeah,
okay.
yeah.
Okay, I'm just gonna need to name it. What I pasted there, the test plot of Blueberry. I know it's not the most close on 20 minutes, but what I mean by this is really cheap land just next to the sea could be purchased because it's salty land. But doing hydroponics and,
Oh,
and having reverse osmosis, that's a possibility.
how much
Because
is that
as a,
land?
the one next to the sea that's very salty that nobody wants,
Yep.
you could get a hectare for at max 50,000 pesos, which would be 2,500 pesos.
2,500 USD.
Sorry, USD. And I think I'm
Sounds like
going,
sounds like an OSE campus
oh,
territory.
yeah, yes,
Wait, but why wouldn't you have? So you haven't ever considered going there because I mean, if the
I
land
need,
is because you got land.
because I need clean water to irrigate my plants. I cannot do it with salty water.
No, exactly. If the RO was solved, would you get some land there?
Yeah, absolutely. I mean, if I'm doing hydroponics, that's the perfect solution in the economic perspective. I get cheap land, and if I have reverse osmosis really near zero marginal cost, that could be a solution as well to be able to get into there.
Excellent, excellent. Sounds like OSE future OSE campus, and this could be. Does this sound like potential to? We still got to solve for people, and I'm getting serious about it. I'm getting pissed. We need people. So uh, it could potentially be. I'm seeing more and more possibility where the favorable economics and this crazy R&D and C research and development commercialization project of saving the earth with open agriculture and all this could be a big hairy project that people would sign up for and descend from all over the world to a place where visa restrictions are less than the US. So that's definitely on my radar. On the Google Earth, I'm going to share my screen.
Yes.
No, that's exciting. That's exciting. That's a possibility because, I mean, for me, I get excited about the idea where I mean, we're doing something. What you're talking about, open economics and bootstrap funding, the open source revolution is serious business and has the most meaning out of anything on this planet. Huh? Doesn't let me share my screen no more. Okay, I'm looking at the map. You showed me test plot Obregon, Sonora.
Yeah, that was my first.
That's your
Of that.
place, yeah?
Yes, still.
Now, we go about... Oh, the square that was shown, what's the size of that? Is that like a kilometer on each side or something?
The one of the document.
No, the one that you shared with Google Earth, the test plot, Obregon.
Oh yeah, that's square kilometer
Square
or
kilometer, okay.
two. That will be 200 hectares that there are around.
Okay, the land which you say is salty and nobody wants. So, for example, this Campo San Isidro, like, is that salty land, or where are we talking about for salty? Because I see agriculture everywhere. I see all the way to the sea. I'm seeing plots of land that all appear to be used for agriculture. So,
Just get close to the sea, and the land that is next to the sea, that's the salty land that doesn't have higher price.
okay. Um, like, for example, Atanasio.
Yes,
That's scrub, kind of scrub land. Um, like that kind of territory.
correct.
Doesn't have. Okay. Is there access with roads, or would you have to build a
Yes.
bridge across the
No,
canals?
I mean, if you see seawater, of course, there's not going to be canals, but the land that is available, it has road access.
Holy cow! I see. There's land, there's agriculture, right up to certain areas, which then it just becomes, yeah, it looks like, uh-huh, yeah, land that's not used. Uh-huh. But can you explain why, like, right up next to, say there's a canal and there's some land that's obviously not used for agriculture, how can you have conditions for agriculture right across the canal? Is it because they've got desalination plants that make that land work at a higher price?
Oh,
Or
they do more shrimp farms,
treat
which they use shrimp,
shrimp?
aquaculture. Yeah, that's why they use that land that is with some roads. It's a big business here in Sonora, in Mexico, doing next to the sea, and they do like reservoirs with seawater, and that's where they create the habitat for shrimp farming.
Mm-hmm.
But if we're doing hydroponics, which basically we don't need to use the soil, we just need cheap land and access to seawater to be able to treat it with reverse osmosis. That changed the game for
Oh,
hydroponics.
so I'm gonna ask how more. I'm gonna ask Chat how much more difficult. Okay, I'm gonna ask this. How much more difficult is it to desalinate seawater than brackish water that's inland? You think it's
It's going to be more cost
mhm.
because it's going to be more salt. That's the only logic that it will take.
Okay, freshwater brackish treatment. 3.5 kilowatt hours per cubic meter using modern. I see. So it's like it could be. So here it says freshwater brackish treatment is often less than half a kilowatt hour per meter cubed, which is sometimes just filtration, settling, and disinfection. But you say your brackish water is not just simple filtration, settling, and disinfection. You've got reverse osmosis.
My current one, yes. The one I have on the blueberry test plot, yes. It's reverse osmosis.
Okay. Does a RO system for seawater last a shorter time than a brackish water system? Are you familiar with the lifetimes of reverse osmosis systems?
No.
Because what you're doing is you're pushing material through a membrane. I'm wondering if that material gets worn out or not. How long, the bottom line question is, whether you're doing brackish or sea, is how long the membrane lives. Like, does that membrane degrade over time? What is a typical
10 years, but it depends a lot on the amount of salt and contaminated water you have, because at the end, what the membranes are doing, it it comes all the water, and then the membranes are separating with small microfilters that only the water can get through and not the salt and the other components. So if you have more salt and more contaminated components, you're going to use more that filter, and that filter is going to tear off. That's
yeah. But it's not negligible, because expect 5 to 7 years versus 7 to 10 years is a reasonable planning assumption. So it's only a few years, up to 2 times as much, but in the worst case, in the best case, similar lifetime. Yeah. And of course, if I train GPT chat properly, it's going to, of course, say, but if you do open source, you can slash through all of this because you've got the best system design.
correct. And the filters are not the most expensive thing. It's electricity again. So that's the thing.
Ooh. No, okay, okay, I didn't know that. And if that's the case, then we've got it made, because we're going to get that to 1/10 the cost, at
Yes.
least. Uh, for what is your price for RO electricity?
Industrial cost.
Which is?
Um, let me look at the document. I believe I put it here. We saw it in the freeze dried document.
Yeah, yeah. I'm in an
But
open source blueberries. Oh,
me too, but I believe I put it in this document as well.
mm-hmm.
I'm looking for it. If not, I'll go to the freeze dried document. Okay, industrial cost is 0.22 per kilowatt USD.
Industrial is 22 cents per kilowatt hour.
Yes.
I'm gonna kill it with our cost.
And
21
agriculture
cent.
is 0.03.
And what?
Agriculture cost is 0.03.
But
This is
RO
not,
doesn't count as agriculture.
no, agriculture is just for the irrigation systems, but not exactly that technology such as reverse osmosis.
Oh man.
Pricey. Yeah.
Okay, so you're gonna kill it 20x, and 3x if it's agricultural cost. Oh man, this is getting exciting, right?
Slide 13. That's where I got the cost of electricity on the open source work document. open source blueberries.
Slide 13. Wow.
I gotta make sure 100% that arrow is not included. But just for reference, let's say that it's gonna go into industrial cost.
Yeah. Now we got to get those open source. Oh man, so you know, this is a case for, if we're talking about pumping, you got to go. So the universal power supply becomes important, but then if we're doing this, we want to be doing DC to avoid inverters. That's what you got to be doing. And then this would be a good case for upping the power. So that's the universal power supply in a Global Village construction set. Are you aware that's part of it?
I saw the video of the PV panels, and I believe there was some information related.
Yeah, that gets the universal power supply. Yeah. So let's go back to the icons and paste that into our work doc, because yeah, that would be another thing that this would address. So let's see, we've got the universal power supply. Let's see, the heat exchanger, that's another machine that we have. And a heat exchanger is actually relevant to the freeze-dried process, because it's all about heat exchange. It's about pumping and electric motors and heat exchangers. Yeah, so let's place those in.
I believe freeze-dried is evaporation of the water, taking it out, and just leave the rest of it, which is the powder.
And that gets right into your heat pumps and everything, which are important for the homes too, and for your heating and cooling. So we got all this product ecology going on. Gets better by the minute. Let's see.
Yes.
What else we got here? So we've got electric motors are in the system. And if we're doing electric motors, yeah, I mean, we got to paste that in. Okay, so wow, so now we got to look at some economics and look at so if we do the pot, we're still, still a high priority, right? Because let's weigh pot versus freeze-dried process, like return on investment that's immediate. Okay, if you're going to develop the integrated pot with water recirculation, how much are we saving in production costs per? So we have to go through some analysis. How much does that weigh versus freeze-dried fruit process? We have to count up how much does it cost to develop the machines or to source them off the shelf. So why don't we do this for the next time?
Yes.
Let's do one case. We source an off-the-shelf dryer, freeze dryer, but because we know it's about electricity, let's look at the costs of PV needed to run it and how we would run it. If you got PV, are we gonna have to go to an inverter? Or are we gonna, is there any choice to get an RO system that runs on DC? Do they exist? Because let me see. I'm gonna ask chat. Is running DC from PV easier than running DC and controlling voltage? Because we got to control voltage. You got to control voltage and current from DC. Let's call it just voltage, because current will take care of itself. From PV easier than inverting to get that voltage. No, the obvious answer is yes, absolutely yes, because you don't have the sine wave thing. You got DC. Let's see. So often, yes, it is simpler and more efficient to drive DC and control voltages directly from PV using DC conversion rather than first inverting to AC. Yeah, it's a power electronics question. It's not trivial, but we can look into how that would look. I would have to look into it. I don't think the answer is trivial. It's if you really look at the system, is it actually easier to go take photovoltaics and run DC loads versus alternating current loads? Because we have so in a PV system, inverters are used because typically everything is AC, typically. So there's a possibility that maybe that some of this industrial equipment runs on DC, but that doesn't exist because nobody runs PV. You see the problem statement there? Because PV is intermittent, nobody in the world runs DC loads in industry, or at least I think they don't. We do know that just about anything out there is run on AC, but there's a thing called universal motors which run both on AC and DC, right? So yes, maybe we try to go for a system where we were running with universal motors, and then we try to get the voltage. The simplest control is to allow for the motor to run at a speed that depends on solar input. So you've got that 1,000 watts per square meter, you've got a certain voltage that you hit at noon. So one concept for getting the cost of integrated cost of a system like that down is simply biomimicry, meaning it runs faster when there's more sun, it runs slower when the sun sets. Now, that means you design a system to accept that. Nobody designed that kind of stuff because industry relies on 24/7 uptime. So this would be innovation, but that would be cool because then we can create a super low-cost system that works only in the day, enabled by the fact that we're open source, which makes this feasible in the first place. So industry would not do this because it's not feasible, because you can't have 24/7 runtimes. Here we have different assumptions, so that something like that could work, and we avoid the inverters, and our system cost is less than 1 cent per kilowatt hour, because the 1 cent per kilowatt hour assumes inverters, which add to the cost. So we're going to absolutely kill it by innovating on the whole topology, of the system, or what do you call it, the whole system design, the whole, I believe the word is called topology, the actual, all the components we use are going to be a little different. Okay, so this is getting good. It's getting better than ever. Let's get some what's our next step? So definitely we've got the pot. You did some work on generating CAD. Let's
Cost calculation, I think, is
yep.
the next step, at least for me, being able to get to the next goal and show
Mm.
you exactly what are the current costs industry-wise and which are the possible costs achieved by this. What I don't have yet the clarity is now I have a critical path 2026, 2027, which has certain machinery. But being able to take that machinery cost of investing into each and then making the cost of the
Hmm.
finished product while using this open source machinery, that's where I would really appreciate your help on
Yeah.
adapting that.
So I think the best approach would be the blended one, where as soon as you get the economics going, you invest into the R&D. Right now, I bought a skid steer, but we want to build our own. So do what you need to get going and get the revenue to bootstrap it. So it'd be a combined effort. Like I would say, open source as much as you can. That's easy. Like for example, the PV stuff. That is absolute low hanging fruit. There's no trick to it. You already have that advantage because we know how to do that in house. It's easy. It's like you just got to design cheap structures. Cheap structures. Um, Basically, you're already avoiding the super high installation costs from so-called experts and professional installations. This is perfect territory. So you already got that, and maybe because you've got, and if it's 60% energy cost, you just killed it right there. You did it, right? So do
Yes.
that. So now you're going solar freeze dry process. We're just hacking the system with existing components. We buy the photovoltaics. We might buy the machine itself. But if you've got a market, just pitch it to as a sales contract. I'll give you this amount at X. Okay, what kind of numbers are we talking about here? So, a commercial grade freeze dried. Have you looked at the production volumes for a freeze dry machine?
Yes, some machinery. It goes from 15,000 USD, but that only process about each 24 hours, 1,000 USD kilos.
1,000 kilos.
Yeah, but let me do the research to be
Do
really sure.
that, and then all you need to do is throw out some of those numbers and see if what I'm seeing here is if you've got a market, then all you need to do is say, okay, I'm going to use a commercial off the shelf machine. I'm going to power it with my own energy. I'm going to sell this to you at X price and throw that into rapid open source development of the machine and process for the benefit of humankind, or to scale all the or to fund all the other development that you need to do to kill it squared.
Okay,
Right? So
yes.
start with that. I think your answer right now is do the business model that you're going to take to the guy who's buying your powder and say, okay, I'm going to sell to you at that. And then we have to then de-risk this in terms of delivery. So we design, we think about what's a feasible route to get there, and we execute on that. It, I think the PV, yes, we install a bunch of PV. We buy an off-the-shelf freeze dryer. The ideal case is you funded it through Bootstrap, through basically a sales contract, which is a great model, I believe. I mean, that's if you've got the market, then you're done. You did it. For us, like with a house, we thought we had a market. It's the same concept. We're saying, okay, we can sell it at X cost, but we did not get anybody to purchase that house up front. That would be a viable route. So that model could apply, and I want to use that same model for housing too. Like people want to be buying the houses up front, so we have capital to work with.
Okay,
Okay, so you got a clear task for next week.
yes, I'll do that.
I love it. This is getting better by the minute. And it was already awesome. All right.
Very nice. And I'm ready to build. Thank you very much again, Martin, and I'll see you in a week.
Yep. See you then. Take care.
Bye.
Bye bye.
Good.